All right, class. This video covers example 2 on related rates on page 64 of your note packet. So I can't write this on the board, right? But this is the problem that we're doing, okay? So let's read it together. A study prepared for the National Association of Realtors estimates that the number of housing starts in the Southwest N of T in millions of units over the next 5 years is related to the mortgage rate R of T, percent per year, by the demand equation 9n squared plus R is equal to 36, where T is measured in years. What is the rate of change? So when you see the phrase rate of change, you know we're talking about a derivative, right? How fast something is changing. What is the rate of change of the number of housing starts, N, with respect to time T, when the mortgage rate is 11% per year and is increasing at a rate of 1.5% per year? So let's define the variables first, right? N, capital N, from the demand equation, right, is the number of housing starts in millions. R is the mortgage rate, right, the mortgage interest rate in percent per year, and T is time in years. And where it asks what is the rate of change of the number of housing starts with respect to time, right? Well, N is housing starts, T is time, and so the derivative we're looking for is dN over dt, derivative N with respect to time. And we're trying to find that when the mortgage interest rate is 11%. And the mortgage interest rate is increasing at the rate of 1.5% per year. Okay, so we're given dr over dt. Well, the one thing that we're not given is n, okay? The number of housing starts when r is 11 and when r is 11, okay? So we have to calculate that before we can figure out what dn over dt is. So here's the demand equation, 9n squared plus r is equal to 36. We know r is equal to 11%. And so, so now we just got to solve for n after substituting in for r. We subtract 11 from both sides and get 25, and then divide both sides by 9, and we get n squared is equal to 25 over 9. And now, to find the value of n, we take the square root of both sides, and we get n is equal to 5/3. Square root of 25 is 5, square root of 9 is 3. So now that we know what the value of n is, okay, we can calculate what the derivative of n with respect to time is. So here's our demand equation again, and now we got to differentiate both sides with respect to time using implicit differentiation. So the derivative of 9n squared with respect to time, right, we just carry the 9 along, right? It's a multiplicative constant. And derivative of n squared, you bring the 2 down front, subtract 1 from the exponent. 9 times 2 is 18, and then we have n to the first. But we're differentiating with respect to time, so by the chain rule, we got to multiply 18n times the derivative n with respect to time t. Then we add to that the derivative of r with respect to t, which we denote dr over dt. And the derivative of a constant, you know, is always 0. Well, now we substitute n. N is equal to 5/3. The interest rate, dr over dt, right? The interest rate's increasing at a rate of 1.5% per year, right? Dr over dt is equal to 1.5. And now we just got to solve for dn over dt, derivative n with respect to time. Well, 18 times 5/3 is 30. And then we can subtract 1.5 from both sides, move this 1.5 to the right-hand side by subtraction. And now we got 30 times the derivative of n with respect to time is equal to negative 1.5. Finish that calculation. I gotta do some erasing here. So we divide both sides by 30, and we have the derivative of n with respect to time, dn over dt, is equal to minus 1.5 divided by 30. And minus 1.5 divided by 30 is equal to, I'll bring it down here. Minus 1.5 divided by 30 is equal to minus 0.05. This is a decimal. Minus 0.05 what? Remember, right, derivatives are measuring how fast something's changing. Right, so it's like a speed, right? Something for something else. Well, N is housing starts in millions. So the rate of change of housing starts with respect to time is minus 0.05 million households, or excuse me, not households, houses, okay? Minus 0.05 million houses per year, right? Time is in years. Well, if I multiply minus 0.05 times 1 million, I get minus 50,000. So the number of new housing starts is decreasing at the rate of minus 50,000 houses per year. Okay, you write it either way, okay? So housing starts are declining at the rate of 50,000 per year when the interest rate is 11% and the mortgage interest rate is 11%, and it's increasing at the rate of 1.5% per year.